All right, now we're going to do problems 6 through 9 on review day 14. The first one here is a linear approximation. So anytime we see line tangent, we're thinking point and slope. The thing about this is they gave us that. Here the point at x negative 1 has a y value of 4. And at that spot we have a slope of 2. So we actually can build this right away, which was awfully nice of them. And we're trying to figure out what the approximation at negative 1.2 is. So we're going to put negative 1.2 in for here. We'll get y minus 4 equals 2 times negative 1.2 plus 1. That's a negative 0.2. So I get a negative 0.4 plus 4, which gives me 3.6, and that's A. All right, so kind of an easy one there. Didn't need a calculator for that, but you had it if you needed it. This one gives us Tara. She has a heart rate of HT, and we want to know which of the following will give us the average heart rate from 30 to 60. So anytime we see average of this is an average value problem. We're supposed to go 1 over 60 minus 30. So 1 over 60 minus 30, put a 1/30th in front. So not A and not D. Okay, one of them gives us just H of T, one gives us H prime. Now H of T is the heart rate, and so I don't want to take the derivative. I want the actual thing. Whatever I want the average value of, that's what I want inside of the integral. So B is our choice on that one. For this one here, we're given a derivative, and we're told that g of 2 is negative 7, and we want to know what g of 5 is. So a pretty standard initial value problem. Our g of 5 will be, where were we to start with? Negative 7. Plus, how did that change? Well, it went from that time 2 to this time 5, and we're going to use this as our derivative. This was on the calculator section, so now you take your calculator, throw that in, and if you did it correctly, you should have gotten C, 13.899 as your answer. Okay, it's pretty straightforward there. Then our last one takes us all the way back to the beginning. If f is a function that has a removable discontinuity 3, which of the following could be? So here we have a jump discontinuity. We're not going to be able to remove it by just simply redefining or plugging the hole. B is also a jump discontinuity. We can't bridge this gap by just simply plugging a hole. D has a vertical asymptote. We got a lot of problems there. C, however, we could remove by just simply redefining that point as right there. Plug it up, it's been removed. All right, that's what a removable discontinuity means. And so C was our choice for that.